Have you ever been on a plane landing in weather so thick you can't even see the wing? And you think to yourself, how on earth are they doing this? Well, today we're going to pull back the curtain on the incredible tech that lets pilots see the unseen.
So just imagine it. You're on that flight, coming down through these thick, soupy clouds. You look out the window, and there's nothing but gray, an absolute whiteout. And then, just moments later, bump. The wheels hit the pavement, a perfect landing. How in the world does that happen when the pilots can't see a thing?
Well, it's not magic, but it's pretty darn close. It's a brilliant piece of engineering. The plane is literally riding a highway of invisible radio beams that guide it all the way down to the runway. And that system has a name, the Instrument Landing System, or ILS for short. Now, what's really interesting is that it's ground-based. We're not talking about satellites here. So the big question is, how does it give pilots the two pieces of information they absolutely need? Am I lined up with the runway? And am I coming down at the right angle?
Okay, so let's dig into the problem this whole system was built to solve. And it's a huge one. Landing an airplane completely blind, totally surrounded by clouds.
You gotta remember, in those moments, a pilot is flying by instruments alone. They can't trust what their body is telling them. The ILS becomes their eyes. It's their unwavering guide through the storm.
Yeah, a guide. And probably the best way to picture it is like a set of invisible train tracks in the sky. It creates this perfect, stable path that leads right to the touchdown zone on the runway. So how does the system actually make these invisible rails? Well, it's broken down into two main parts. First, you've got the localizer. Think of this as your left-right guidance. An antenna at the far end of the runway shoots out two beams. If the plane picks up one, it knows it's too far left. If it picks up the other, it's too far right. Then you've got the glide slope. This is your up-down guidance. Another antenna sends out two more beams, one above and one below the perfect 3-degree descent path. The pilot's whole job? Keep the needles for both of these perfectly centered. Stay in that sweet spot where all four beams cross and you're golden. Okay, but you can't just follow this thing blindly all the way to the ground. There's a super important safety check built in. It's called the decision height. This is a predetermined altitude, a real moment of truth, where the pilot has to look up from the instruments. If they see the runway lights, great, they can land. But if they see nothing but fog, they have to power up, go around, and execute what's called a missed approach. It's not about blind faith. Safety is literally built into the process. Right. Now, as you can probably guess, not all bad weather is created equal. A little bit of haze is totally different from a zero-visibility blizzard, and the ILS is smart enough to have different levels for that. So to deal with this, the whole system is broken down into different categories. Each category is designed for progressively worse weather, and as the weather gets worse, you need better equipment on the ground, better equipment in the cockpit, and of course, more specialized training for the pilots. Let's actually look at the breakdown. The most common is a Cat I approach. That lets a pilot fly down to 200 feet above the ground. At that point, they have to see the runway. But as things get worse, we move up. A Cat 2 lets them go down to 100 feet. Then we get into the really serious stuff. Cat 3. Cat 3A lets you get even lower. By the time you're at Cat 3B, your decision height might be less than 50 feet, with barely any forward visibility. And then there's the Holy Grail, Cat 3C. This one has no decision height and no visibility rules. This is for a full auto land, where the autopilot literally flies the plane all the way to touchdown in complete 0-0 conditions. It's just incredible. So what's this actually like for the pilot? Let's put ourselves in the cockpit and walk through the steps. Okay, so here's the playbook. First up, tune and identify. The pilot tunes the right frequency and listens for a little Morse code identifier. You gotta make sure you're locked onto the right runway after all. Next, set the course. They dial in the runway's heading. Then, intercept. Air traffic control gives them a heading to capture those invisible rails. Then comes the really hard part, fly the approach. This is all about intense focus, making tiny adjustments to keep those needles dead center. And finally, we're back at that critical moment, decide at DH. At the decision height, they look up and make the call, land or go around. Now, this system is incredibly reliable, but it is not foolproof. It demands absolute concentration from the pilots, because even a tiny mistake can become a big problem really fast. So what can go wrong? Well, for one, you can get a false glide slope signal, which could try to trick the plane into a dangerously steep descent. Simple stuff like setting the incorrect course or the wrong frequency can mean you're following a path to a completely different airport. And probably the biggest one is just a poor instrument scan.
If the pilot gets distracted and stops cross-checking everything, the plane can easily drift off course. This is exactly why their training is so intense.
So you might be thinking, wait, what about GPS? Isn't that more modern? And yeah, GPS is amazing, but the ILS is still number one. It is still one of the most reliable, most trusted, and most used precision landing systems on the planet. And that is a real testament to its brilliant, robust design. And that's the real takeaway here. The ILS didn't just improve aviation, it completely revolutionized it. It took weather cancellations, which used to happen all the time, and made them rare. Without it, the reliable global air travel that we all kind of take for granted today, well, it just wouldn't be possible.
You know, the ILS is such a perfect example of a complex, invisible system working flawlessly in the background, 24/7, just to keep us safe. And it really gets you thinking, what other unseen networks are out there, quietly making our modern world work? Something to think about. Thanks for joining us for this explainer.